Hey everyone, I wanted to go over the group anagram problem. This kind of builds on the is anagram problem that I went over the other day. A little bit more complicated, but nothing too fancy. Fun one to work through with arrays and hash maps. So let's jump into it. All right, I got the scaffolding of this built out. I'm just going to quickly walk through what we're doing here. This is the array we would expect. You know, we have something like 8, eat, dog, and God. We know there are going to be 2 groups of anagrams in this. And what we're going to do is build out the hash map. Shocker. No, you must be surprised. We're going to take the word and sort it alphabetically and build out the arrays that way. Then we'll be able to loop over that at the end to build out the result itself. So just to reiterate, we're going to sort the word alphabetically. We're going to update the hash map. At the very end, we'll return the values in the required format. All right, first, let's actually create the hash map. So we'll say groups, if I can spell, make map, and the key is going to be a string, and then the value is going to be an array of strings, keeping track of the words. From here, let's say for, we don't need an index. We'll say word in range of words. And in Go, we can use the bytes because we know those will be able to we will be able to sort the bytes. So here we can say bytes, and we can do an array of byte. We'll pass in the word. So now we have that. Let's sort the word. So sorted. All right, now that we got the bytes, we can do sort. I believe it's slice. Yeah, then slice, we'll pass in bytes. And then we have a function. If you're used to JavaScript, it's similar to that, right? And here's the function you expect to be operated on for all the sorts. So say I and J for now. We know they're going to be ints. So we'll return a bytes I is less than bytes j. Got that? All right, now we've imported that library. What am I missing? Oh, I need to have the return type. Okay, now I have this. Let's actually turn these sorted bytes back into a string. String bytes. Okay, from here, this is where we want to build out the hash map. We will say groups, sorted string equals append, right? And we'll say the word itself. So what we're doing here in the example that we have above, we're turning the hash map into AT, and then we're adding this array of the 8. And every time we loop over these words, we're going to continue to update this hash map. Okay, now that we have that, let's figure out how we're going to update this result so it has everything we're expecting. Say for, we're going to loop over the group itself, range group, groups, and just results equals append the group or the results group. All right, let's run our tests and see if this works. All right, looks like everything passed. So let's just go through what we did here and reiterate kind of more of the sticking points. First, we're going to loop over all the words, and we want to split them into bytes so that we can sort them alphabetically. Once we've sorted the bytes alphabetically, we're going to combine them into a string again. This is creating the key that we're going to store in our hash map. We're going to do this for every word in the list, and then at the end, because of the way we need to have what the return type is, we're going to loop over these groups and just append them to the result. I found this to be the most straightforward way to think through the problem, and hopefully it helps you. All right, see you in the next one.